Comparison between streamlined flow of liquid and turbulent flow of liquid. Left hand side we can write streamlined flow, and right hand side we can write turbulent flow of liquid. This is the streamline in a tube, streamline along which the particles of liquid travel. On this streamline we can denote 3 points A, B and C. A, B, C are the 3 points. First diagram is at an instant t equal to 0, and the second diagram is at instant t equal to t second. Now the particle 1 at the point B at instant t equals 0 has the velocity vector v1, and particle 2 at the same instant t equals 0 has the velocity vector v2 at the point A. After some time, that means at instant t equal to t second, particle 1 will reach to the point C, and at the point C, particle 1, liquid particle 1 has a velocity vector v1 prime. And at the same instant t equal t second, particle 2 will be at the point B with and that will be moving with the velocity vector v2 prime. And for streamline flow, vector v2 prime will be equal to vector v1. While crossing the point B, the particle 2 will have the same velocity as that of the particle 1 at instant t equal to 0 second. While crossing the point B, vector v2 prime will be equal to vector v1. That means velocity of the particle 2. Velocity of the particle 2, that means vector v2 prime is the velocity of particle 2 at the point B at instant t equal to 0. v1 is the velocity of particle 1 at the point B at instant t equal to 0. Similarly, on the right hand side for turbulent flow, particle 1 had the velocity vector v1 at instant t equal to 0. Particle 1, liquid particle 1 at the point B has the velocity vector v1 at instant t equal to 0, and at the same instant particle 2 was at the point A and it was moving with the velocity vector v2. After some time at instant t equal to t second, particle 1 reaches to the point C and has the velocity vector v1 prime, and particle 2 will reach to the point B and it will have the velocity at the point B at instant t equal to t second. Particle 2 at the point B at instant t equal to t second will have the velocity vector v2 prime. While crossing the point B, for turbulent flow, vector v2 prime is not equal vector v1. That means particle 2 will not have the same velocity as that of its preceding particle 1. At instant t equal to t second, particle 2 at the point B will have the velocity vector v2 prime along this tangent, but at instant t equal to 0 second, particle 1 was at the point B and velocity was vector v1. And in this case, for turbulent flow, vector v2 prime is not equal to vector v1. Number 2 comparison for streamlined flow, it is a regular and orderly flow of liquid. Right hand side, it is an irregular and disorderly flow of liquid. Number 3 difference or comparison between streamlined flow and turbulent flow will be what? Number 3, every particle of liquid while crossing a given point has the same velocity in magnitude and direction as that of its preceding particle. And every particle of liquid while crossing a given point in the liquid has different velocity different velocity from the other particles. Number four difference is, or comparison is, the velocity of liquid flow is less than the critical velocity. The velocity of liquid flow is less than the critical velocity. For turbulent flow, velocity of liquid flow is more than the critical velocity. Number five difference. The energy of liquid is used for its onward flow of liquid only. That means in liquid flow in the forward direction, most of the energy on the right hand side for turbulent flow, the most of the energy is spent in forming the eddies. The most of the energy is spent in forming the eddies for turbulent flow on the right hand side. Number 6 difference. Viscous force, that means if V dominates over the inertial force, viscous force tries to keep the liquids in different layers. This is the first layer of liquid, and the upper layer is second layer of liquid, which is moving with greater velocity. Distance separation between the two layers is dx. First layer is moving with velocity v, second layer or upper layer is moving with velocity v plus dv. F is the inertial, Fi is the inertial force, and Fv is the tangential opposing force or viscous force which opposes the relative motion. In this case, second layer has the velocity v plus dv, and inertial force acts in the forward direction or towards right. This is the inertial force Fi. Inertial force. In the diagram, Fv is greater than Fi. For streamline flow or laminar flow, because laminar flow is one type of streamline flow, Fv is greater than Fi, right hand side. Inertial force Fi is much greater than the viscous drag or viscous force Fv. In this case, we can make a correction. Inertial force Fv, viscous force will have smaller magnitude, and inertial force Fi will be acting towards right with the greater magnitude. Viscous force Fv has the smaller magnitude. In this case, for turbulent flow, inertial force Fi should be greater than the viscous force Fv. That means Fi greater than Fv. Number 7 comparison is the value of Reynolds number for streamline flow or laminar flow. Laminar flow is one type of streamline flow. Laminar flow is a streamline flow which flows in the form of layer. The value of Reynolds number for streamline flow lies between 0 to 2000, and the value of Reynolds number for turbulent flow on the right hand side for turbulent flow is more than 3000. We can draw a tube, horizontal tube, through which liquid is flowing. This is the axis of the tube, horizontal axis of the tube. We can denote the axis of the tube through which liquid will be flowing in the form of different layers. We consider a certain line or imaginary vertical line, and this line indicates that different layers of liquid will be moving towards right with the same velocity magnitude. These are the different layers of liquid having same velocity in the same direction, and we get a straight line velocity profile. This vertical imaginary line is the velocity profile, and these are the different layers of liquid having same velocity in the same direction, having same velocities or velocity. After some time, velocity of the layer along the axis will be maximum. This is and we can denote the velocity profile for streamline flow. This imaginary curved line is the velocity profile for streamline flow. This is the velocity profile for laminar flow or streamline flow, which connects the different layers of liquid, in which the velocity of the layer along the axis will be maximum, and the velocity of the different layers from the axis to the wall of the tube decreases gradually. In this way, velocity decreases. These are the different layers having different velocities, and these velocities will decrease from the axis of the tube to the wall. Along the axis of the tube, liquid will be flowing with maximum magnitude, maximum velocity, and at the wall, liquid will be at rest. And here we have denoted the velocity profile for streamline flow or laminar flow. This point indicates that liquid will be at rest at the wall of the tube. These are the 2 points. We can consider another imaginary vertical line from which we can denote different layers of liquid with different velocities. Now we can draw velocity profile of liquid for turbulent flow. This is the imaginary line, that is the velocity profile, and we can denote different layers of liquid having different velocities. So these are the different layers of liquid having different velocities. In turbulent flow, these are the different layers of liquid will be flowing towards right having different velocities. Velocity of the layer near the wall of the tube will be 0, and this sky colored curved line is the velocity profile of liquid for turbulent flow. This is what the velocity profile. This is the velocity profile of liquid for turbulent flow. For turbulent flow. In this way, we can compare the velocity profile of liquid for streamline or laminar flow and turbulent flow. We can denote streamline region and turbulent region. This region indicates the streamline region. In this region, the flow will be laminar or streamline. So in this region, liquid will follow laminar flow. Liquid flow will be laminar flow, and here this region, in this region, liquid flow will be turbulent. Between laminar flow and turbulent flow, there will be transition phase. There will be transition phase in which liquid flow will be converted from laminar flow to transition flow. And in transition phase, different layers of liquid will be flowing in this way, in different directions. In different directions. These are the direction along which different layers of liquid will be flowing, and eddies will be formed in this turbulent flow or transition phase. These are the direction along which different layers of liquid will be flowing and eddies will be formed. And now we can denote streamline flow of liquid through a tap. When the tap is opened, in that case, initially, liquid will be falling, maintaining streamline flow. This is the streamline flow or laminar flow. That which means what? And on the right hand side, for turbulent flow, different layers of liquid or different lines will be flowing in this way, disorderly. These are the different lines along which liquid will be flowing, and this is obviously irregular flow, and it indicates that this flow is turbulent flow. if the tap is opened, a number of streamlines along the axis of the tap, will be observed, and the flow of liquid through the tap will be streamlined. On the right hand side, for turbulent flow, if the tap is opened for full flow, a number of lines will be broken. A number of lines is broken and eddies are seen, and the flow of liquid through the tube or through the tap now becomes a turbulent flow. The flow of liquid through the tap now becomes turbulent flow. For streamline flow, viscous drag is greater than inertial force, and for turbulent flow, viscous drag F V is less than inertial force F.